Dear students, I start with lecture 18 of 201. Have a look. There are definitions and some notes. So first let me explain what are the definitions, and then you can see the actual understanding. You can understand what is the actual definition for your understanding. See here, I am taking the two-dimensional figure. Suppose this is a local maximum, means among certain region, this is the maximum value. You see? This is the maximum, and I say this point say AB, means this value is maximum. So let E subset R to F is function from P to R. We say that F has local maximum at AB if f of A plus H B plus K less than or equal to F of AB, means all these points, if we see this, all these points, they have less value than F of AB, means it is local maximum. આ કેવું છે છોકરાઓ કે આપણે તમારા ક્લાસમાં મારે વાત કરી અને તમે જેટલા છોકરાઓ છો અત્યારે લેક્ચર સાંભળી રહ્યા છો કે પછી સાંભળશો કે તમે જે ટીવાયમાં છો, એસવાયમાં છો, સેમ 3માં, તો તમારામાંથી કોની મેક્સિમમ ઉંમર છે, તો એ જે મોટામાં મોટો વ્યક્તિ હશે એ લોકલ મેક્સિમમ ઉંમર વાઇઝ થશે. હવે એમાંથી જે સૌથી નાનું હશે એ ઉંમર વાઇઝ લોકલ મિનિમમ થશે. લોકલનો મતલબ સ્થાનિક થશે. ક્લિયર? આ લોકલ મિનિમમ માટે છે. This is for local minimum, this is for local maximum. Local minimum figure is like this. Suppose if we extend this one and say this point where we have the minimum value, all other values are more than this value. At that time we say that this is local minimum. At this time we say that it is local maximum. But if it happens, if F has local maximum or local minimum at point AB in E, we say that F has local extreme value at AB. In the second one, F of AB less than or equal to F of XY, means this is the minimum value. And this is over the whole set E. And this is over N. N for neighborhood. Neighborhood of AB. And E for the whole set on which the function is defined. This is absolute global minimum. એટલે કે આ આખા જેમાં સૌથી નાનું છે, અને અહીંયા જો આગળ ડેફિનેશનમાં જશો તો આ આખામાં સૌથી મોટું છે. We call it absolute global maximum. This is absolute global minimum. Like that. Now you understand this definition, so try to capture the idea. This is local maximum, local minimum. This is global maximum, global minimum. So I repeat again, this is maximum among neighborhood, means it is maximum among this. All values of f at this point is less than or equal to this point, means this is the maximum. All values within n at this point is minimum, means this is local minimum. Then this is maximum among all values, means it is absolute global maximum. If it is maximum. If it is minimum, then we say that it is absolute or global minimum value. Here, if it is maximum, then global maximum. If it is minimum, then global minimum. Local maximum, global maximum, local minimum, global minimum. Dear students, there is one theorem on the board. If f has extreme value at AB, then prove that fx AB equal to 0 and fy AB equal to 0. Means a function has maximum or minimum at AB, then prove that the derivation with respect to x and y are 0. So we start the proof. If f has extreme, extreme means it is maximum or minimum, but here we choose maximum. Suppose f has maximum at AB, therefore for all h, for all h, therefore positive real, for all negative here. Therefore, this is always less than or equal to 0. Now, if h is positive, then the less than or equal to 0 will be less than or equal to 0. But if h is negative, then this less than or equal to 0 will become positive. Means maybe 0 or maybe positive. Therefore, now we are given that partial derivations are exist, means it is positive side, negative side and at a point. All these three are equal. But positive differentiation is less than or equal to 0, negative differentiation is greater than or equal to 0. This means that fx is equal to 0. We can prove this by the similar way. Also, we can prove in the minimum value, therefore, so just have a look. Here we choose f as maximum, and in the last line I read that also we can prove similar result in the minimum value case. Means we can do the same again for the minimum value case. In this we prove that this is global maximum, okay, or local maximum. We choose that this is less than or equal to this, then change side of this means less than or equal to 0. H positive, then this is less than or equal to 0. H negative, then this is greater than or equal to 0. But this is fx plus ab, and this is fx minus ab. All these three values are equal. This is less than or equal to 0. This is greater than or equal to 0. This means that all these values are 0. And similarly, with respect to y, it is 0. Okay, so it is like this. So remember, R is f(x)x, S is f of xy, and T f of yy. So you have to remember R as T. f(x)x, R, f(xy), S, f(yy), T. R, S, and T. And there are three tests. RT minus S square is greater than 0, R negative, then F as maximum. RT minus S square greater than 0 and R less than 0, F as a local minimum. If it is RT minus S square is less than or equal to 0, then test fails. So in the table, if we want to understand this, then it is like this. R is f of xx, S is f of xy, and T fyy. Now RT minus S square, if it is positive, two possibilities. If it is positive, if it is less than or equal to. If it is positive, then there are two ways. R positive. R positive. F as minimum. R negative, F as maximum. If R less than 0, then it is maximum. If R positive, then it is minimum. And if this is less than or equal to 0, test fail. We cannot say. So you have to remember like this. R for f of xx, S for f of xy, T for f of y. As I will take sums, you will understand it more clearly. But as of now, R is f of xx, S is f of xy, T is f of y. R S T, xx, xy, yy. If RT minus S square positive and R positive, minimum. RT minus S square positive, R negative, maximum. If it is less than or equal to 0, test fail. Check it. So on this chart you will understand it more clear. So all these things are required to find the points of extreme values. But I stop this lecture here and we'll continue lecture in the next time, in the one more lecture. Thank you very much.